Hey everyone, and welcome. Now to all the business analytics students joining us today, we're going to be looking at one of the world's oldest industries, but we're going to treat it like a massive, complex systems engineering problem. Over the course of this explainer, we're exploring exactly how traditional agriculture in Vietnam is transforming. It's shifting from this highly inefficient linear process into a brilliantly optimized, data-driven, closed-loop system. Seriously, if you're the kind of person who geeks out over mapping out process optimizations, you are absolutely in the right place today.
All right, here is a quick look at our roadmap. We'll be covering 1. The linear bottleneck, 2. The circular architecture, 3. The tech upgrade, and finally, 4. Enterprise scale. Let's get right to it.
Starting off with Module 1, the linear bottleneck, or the inefficiency of the traditional take-make-waste model.
Okay, let's dive into this. Vietnam's agricultural sector is without a doubt an absolute economic powerhouse. Just to give you a sense of its sheer weight, look at this number on the screen, over 48 billion US dollars. That was the export revenue generated by commodities, things like rice, coffee, and seafood in 2021 alone. It employs roughly 38% of the workforce and has virtually wiped out food insecurity in the country. It's incredible. But here's the catch. Running a multi-billion-dollar machine at this massive scale using a traditional linear take-make-waste model, well, it creates a monumental data and efficiency bottleneck.
And this brings us to a really jarring piece of cognitive dissonance, because right alongside that massive revenue, this system spits out an estimated 95 to 98 million tons of agricultural residue and byproducts every single year. Just let that sink in for a second. Furthermore, intensive traditional rice production alone accounts for a staggering 75% of Vietnam's total national methane emissions. I mean, think about that from an analytics perspective for a moment. That is an insanely high level of waste and harmful output, all generated by things like inefficient irrigation, poor fertilizer application, and untreated livestock byproducts.
So this perfectly illustrates the core conflict we're looking at. On the left, you've got linear agriculture. It's basically a leaky bucket. High emissions, rapid resource depletion, and a super inefficient ratio of inputs to outputs. It relies way too heavily on buying external, expensive chemical fertilizers and pesticides. But over on the right, we have circular agriculture. And as business analysts, we really need to start looking at this like an elegant, optimized algorithm. In a circular system, waste is recycled, resource efficiency gets maxed out, and the outputs, or the waste, of one specific process are instantly routed to become the essential fuel for the next one. It's brilliant.
Moving on to Part 2, the circular architecture. Let's look at some traditional closed-loop systems.
You know, what's fascinating is that historical farming practices actually solved these exact bottlenecks long before computers were ever a thing. Let's break down the traditional VAC system. VAC stands for Vườn Ao Chung, which translates to garden, pond, and barn. Honestly, this is a perfectly mapped process loop. So the farmer plants fruits and veggies, raises fish in the pond, and keeps pigs in the barn. It is a biological routing masterpiece. The waste from the pigs in the barn fertilizes the garden and the fish pond. Then, the aquatic plants from the pond are harvested to feed the livestock, and the nutrient-rich water from the pond gets routed right back to irrigate the garden. It is literally a closed-loop system achieving zero waste through clever, localized design.
Oh, and here's another amazing example. The rice duck ecosystem, which is used heavily in the Red River Delta. Think of this one as a symbiotic algorithm. By introducing 3-week-old ducklings into the rice paddies, the ducks provide completely natural pest control. They just wander around eating the insects and weeds, which entirely eliminates the need for expensive chemical pesticides. Meanwhile, their waste provides natural fertilizer for the rice plants. The farmer ends up with 2 profitable output streams, rice and duck meat, while slashing their input costs down to near zero. Talk about a win-win, right?
All right, on to Module 3, the tech upgrade. Eco-innovations in analytics. Now, what's really interesting about this next slide is how it bridges the gap to what you do.
Because this right here is exactly where your skills as business analytics students intersect with agricultural science. Today, this whole sector is being completely revolutionized by digital tools. We're talking about IoT-based smart irrigation systems using real-time sensors to track soil moisture and optimize water usage on the fly. We've got drones and remote sensing flying over fields, monitoring crop health and executing highly targeted pest control. Blockchain technology is stepping in to provide totally unparalleled supply chain transparency, which actually allows sustainably farmed products to command premium prices in the market. Even out in aquaculture, we're seeing automated aerators and feeders powered entirely by solar energy. Every single one of these data touchpoints is being analyzed to minimize resource waste and absolutely maximize ROI.
But hey, the hardware is only half the story. Biological technology is also supercharging system efficiency in ways you wouldn't believe. Take the black soldier fly, for example. Just 1 ton of black soldier flies can biologically process up to 80 tons, yes, 80 tons, of organic domestic or livestock waste. They transform it into highly valuable organic fertilizer and protein-rich animal feed. Or look at biogas digesters. These capture the methane emitted from livestock manure and convert it straight into renewable energy for cooking and feeding. It literally takes a massive greenhouse gas problem and flips it into an off-grid energy solution. How cool is that?
Okay, let's move on and see how this builds into part 4, enterprise scale. We're looking at industrial zero-waste business models. Because, look, we're no longer just talking about small, localized family farms here. The crucial takeaway is understanding the 4F model. 4F stands for farm, food, feed, and fertilizer. Initiated by the Qualium Group back in 2020, this represents the ultimate business application of everything we've talked about so far. It is a holistic, industrial-scale agricultural model that operates on the strict, non-negotiable premise of zero waste. Advanced science and technology are applied at every level to ensure that the output of absolutely every production process directly serves as an input for the next.
So, let's map out this 4F closed cycle together. Step 1. Industrial pig raising generates massive amounts of waste. Step 2. Instead of letting that pollute local waterways, that waste is collected and meticulously processed using microbiological techniques into high-grade organic fertilizer. Step 3. That microbial fertilizer is then distributed to farmers who are growing maize, tea, and fruit all across the country. And finally, Step 4. Those crops become the high-quality, safe animal feed required back in Step 1. By locking this whole process into a closed loop, the corporation prevents disease, drastically cuts down greenhouse gas emissions, and massively scales up profitability. In fact, this specific model has already been successfully scaled across 30 different provinces in Vietnam.
So what we're really seeing here is the realization of circular economic principles, applied from the very first moment of agricultural production all the way down the line to end consumer consumption. It's just a complete, incredibly data-friendly supply chain optimization. By integrating traditional biological logic with modern data processing, we get industrial production that actually regenerates the environment, rather than just depleting it.
Which brings us to a final challenge for all of you watching this explainer. You've seen how these traditional closed loops have merged with high-end digital tools to create multi-billion-dollar zero-waste enterprises. As future business analysts, the data points in these systems, from IoT soil sensors to biological waste conversion rates, well, they're just sitting there, waiting to be optimized even further. So I want to leave you with this provocative question. How are you going to use your systems thinking and your data analytics skills to discover the next massive efficiency in this circular agricultural loop? Because honestly, the future of sustainable food production might just depend on your answer. Thanks for watching, everyone.